Hi, everybody. Thank you, Brandon. Thank you for the chance to be here. It's an honor and a pleasure. My name is Addante. I'm also a professional research psychologist at California State University in San Bernardino. I run a cognitive neuroscience lab. And I'd like to share with you a little bit of our experiences being a crew member, particularly informed from the vantage point of also being a professional psychologist and a PI in the lab and on other analogs like NEEMO. So let's see if I get these buttons right. A couple things right off the bat that I wanted to share, that maybe some things that PI should know about analog crews. So one of the things I learned from doing the NEEMO mission this past year is something that came from the director for many years from that. Bill Todd told me that the #1 thing he's seen in decades of work with the shuttle training and for running these NEEMO missions is that if any other factor was out of the equation, if only the crew continued to believe in the mission, you had every opportunity to succeed. And that's something that stood with me, and I'm going to share a little bit about what that's like as a crew member, about where sometimes some things can come in as threats to that belief in the mission sometimes that can improve our data. So some things that PI should also know about analog crews. One, we're not real astronauts, we're fake. So like in the movies, you might remember Armageddon, you had a crew that was taken off the streets with about 2 weeks to train. They had no idea what they're doing. You're scared, but you're also excited, and it's a great opportunity, but we're gonna make some mistakes. We're gonna bring some assumptions, we're gonna bring some perspectives to the table that might be different from what is true, most certainly. It might be different from what you might normally expect in your research lab at the university or your institute or what have you. So it's kind of like this for us. We're gonna feel kind of like this, and that we're gonna be asked to put together rovers and robots and all sorts of things that are gonna be confusing to us. Oftentimes we might feel inadequate, and we might screw that up, and that might make you at NASA feel like this. Many of you guys might have tested me in those environments, and I'm sure I gave you that feeling probably daily. So I apologize for that, and thank you for not kicking me out. So the gist that I'm going to cover today is this idea that crews are going to think that the missions will be perfect. They don't know what you're not testing, which is something that can be really helpful to think about. They also don't know that you're not testing them necessarily. And this is a theme that I'll return to kind of consistently in the sense that it's helpful to take what I call a test pilot state of mind, which is that we're beta testing. And so it's very helpful to put the crew at ease sometimes, in my experience and what I've talked with the crew, in that if we know that if we fail on something, or we screw something up, or even if a task happens to screw up, that we're not failing at a personal level. We're not being judged, we're not being evaluated in that sense, but we're actually helping to test the systems, the technology, your studies. And so that helps to do what I'm going to refer to as communicate a lot and build this one team idea across both crew and PIs. So if you think about it in this way, I like to think about it as being the test pilots of the human mind. And you guys all work with HRP in one capacity or another, so you guys are all test pilots of the human mind. We're trying to figure this out. And in 1959, the unknown systems for space exploration was machine. So what we did very intelligently is we took a bunch of mechanical engineers who were test pilots, and we said, can you test these mechanical systems? And they went up in the rockets, they did a wonderful job. And the thing that we did not do was send this gentleman on the right here, that's B.F. Skinner during the same time as the Mercury program. He was one of the world's top psychologists. We did not send him to test our engineering. However, in 2020, the unknown systems for space exploration are human. We have rovers and robots already on Mars. Our rockets can work preliminarily for that purpose, but we still need to figure this human side out, and indeed that's why we're all here. We all care about that and very passionate about it, but very rarely do we have psychologists kind of give some beta feedback from that test flights the way that we did from our mechanical engineers. So I'm here to kind of share a little bit of that perspective. So our team in HERA was in 2017. We were graced with a wonderful team. One of them here is also Reinhold. He did both the NEK mission as well as ours. We also had Shelly Cazares and Paul Haugen. It's blessed with a great crew. And they're very accomplished. They have lots of PhDs. They were finalists for the astronaut selections. They are engineers. Paul flew the T-38s for NASA at Ellington for a long time. Shelly worked at the Pentagon, MIT, Oxford. Highly accomplished groups. We were highly motivated, and we totally screwed up some tasks for you guys. And I'm going to share a little bit about that, because if it can happen to us in that mission, it can definitely happen to you. It can happen to your projects. It can happen to your data. And so I want to share that. Because your mission is really difficult, but it's really important, and I want to underscore that after being a crew and working on the PI side now, I have a profound appreciation for what it is you all do in the room and how difficult this is. You guys do a very, very difficult job, and I have a profound appreciation for that. So some perceptions that we have as crew are not reality, and some things that I thought would be important to share. As I mentioned, a lot of times we think we're being tested personally, mostly because you're testing us personally. But we're going to make mistakes, we're going to screw that up, and if we can be informed through communication, building that trust through good briefings early and often, that if something happens, if we mess something up, not to take it personal, we're test pilots here, we're testing to what extent are the boundaries of our systems, where do they have failure points, where do they have stress points. I think that that will help to de-stress sometimes some excited and overwhelmed crews who you're also sleep depriving. So it's important to communicate that things are going to go wrong, and it's okay not to take it personal. Accordingly, we often think, wrongly, that everything at NASA is a psychology test. So we think everything that's happening, every mistake that might happen, or anything like that along the operations side of the mission, they must be messing with us. This must be one of the tasks. This must be one of the measures. Most of you guys in the room know that's probably not true. Accidents happen, things happen. I would encourage a little bit more consideration of disclosing some of that information, because it can put your crews at ease and help them give more accurate data for the things you are measuring, rather than creating artifactual responses of some of their perceptions that might not be true. So disclosure is your friend. So not just what you are testing, but if you're not testing something, hey, this isn't part of the thing, we're just having a hiccup here on the comms. Okay, awesome, thanks for letting us know. And finally, in terms of that big picture teamwork, reminding them that we're all on the same team. I know that you guys do this a lot in MCC and operations anyways, but it's helpful from the beginning, through the middle, and through the end, because we're sleep deprived, we're forgetful, and we're kind of like your children in that when you tell us things, we will forget, and you're going to have to tell us again. So we're being reminded that MCC, operations, and the crew, they're actually all on the same team together. It's kind of like air traffic control system. We can't see where we're going in the fog, and we need you guys to let us know as a team, eyes and ears, and if that can help kind of get rid of that us versus them that might happen sometimes in crews. So that brings me to the next idea I want to share, which is this idea of interstudy impacts. So that is, your data is affected by other PIs, and other PIs are affecting your data. So what do I mean by that? We're one big team, and something that Paul Huggin, co-author on this presentation, wasn't able to make it today. He said, when items repeat across surveys or are worded badly, you tune out. And when you tune out on one survey, you tune out on all. And everyone I've talked to from crews all across different analogs couldn't agree more on that. So it was something that a lot of people encouraged me to share. So we are happy to be your lab rats, your guinea pigs, or your research monkeys, but anyone who works in systems neuroscience or psychology knows that there's a cardinal rule you do not want to violate, which is you do not want to make your monkey mad. So I'm here to let you know what makes some monkeys mad. What can be problematic in the crew experience? One, bad tasks. You're not going to know this at the time because you think your task is great, because that's why we've already approved it and you've beta tested, you brought it in the project. However, sometimes some questions seem repeated, sometimes they seem poorly worded, and sometimes some tasks might fail or they might seem like they fail. And I say seem on those things because that's our perception and that's not always reality. Sometimes it might be worded perfectly well, but we don't realize that, and it might seem like it's worded poorly. That takes us out of a little bit of belief in that mission. I'll explain a little bit more. Too many surveys, as you guys know, you probably heard this a lot, saturation effects, as I call it. Survey questions that are too many. So just standard fatigue effects in the laboratory that most psychologists might be a little bit more familiar with research methods classes. Saturation effects maybe not so commonly discussed in the field because we tend to report projects and papers that say we tested somebody in a task, and we don't say that we also tested them in 37 other tasks that day. But that tends to be the case in these analogs, and that can be okay. It's just a differential aspect of what we're used to in the field. So you select a smart crew, they expect smart science, and they're going to try to figure out what you're doing. They're going to try to figure out your questions. And if there's questions that don't make sense to them, they're going to start to question that, and that can threaten sometimes the crew belief in the mission. So you want to keep your monkey happy, and don't keep him in the dark. You're our eyes and ears, and we rely on you for that trust. So what do I mean by some questions? I'd like to share with you guys something. I want you to ask, or imagine at least, that you're in a camper with 3 co-workers for 3 months in the summer. You can't get out. And I ask you on a scale of, I don't know, 1 to 21, how insecure, discouraged, irritated, stressed, and annoyed you were during each of the tasks you just completed today. So, let's say I ask you that on day 28, okay? What we perceive on this is that there's 5 different things you're asking me in that question. Insecure, discouraged, irritated, stressed, and annoyed. So how do I know which one of those I felt? How do you know, or how do I know which one you meant to ask me about? How do I answer this question if I feel differently about each of these different psychological constructs? This is especially true for team cohesion surveys. They ask about the team. When you have 4 people, you have sub-teams. How do I answer a question about how the team's doing if I'm getting along with one and we're having an awesome team together, but not with the others? The data is completely invariant to what the truth is happening in the team. So something to think about as we design our studies and measures more in the future. So how do we know what the data means? If it doesn't mean anything, how is it useful and why are we doing it? These are questions the crew has go in their mind at times. I certainly did. Those will make your monkeys mad. You don't want to do that. It can also carry over to another researcher's unrelated study that happens right afterwards, right? So none of us are able to turn our moods and emotions off like light switches. That's going to carry over a little bit, and that might be your study that it carries over, and your study might not have done that at all, and now it's been contaminated by something that might have been questioned earlier. So that data risks becoming policy, and I want to encourage that should not be used to drive policy. Even if it is a valid question and is a valid test, which it turns out this actually comes from a task that's validated, I found out when I researched it after the mission, the damage can already be done because I didn't know that. It sure seems like a dumb question. There might be a perfectly good, intelligent reason to ask it, but a little bit of disclosure communication can really help that a little bit, because again, we want to work together on the same team. And the good news for everyone in this room is this is not our problem in the room. It's our problem in the entire field. So psychology does this very poorly, and I say that as a psychologist. How many surveys are too many? How many questions are too many? And what's the right way to ask certain questions? We don't necessarily have standard measures in the field for that. We don't have really good parametric questions to answer that in social psychology. I looked in the research and I couldn't find it. It's possible I missed it, but that's something to think about. And that's also an opportunity that we have to lead the field forward in psychology the way that engineering did, and brought technologies back from the early space program to Earth. We can actually contribute that to the large field of psychology. So some ideas I have on that moving forward. I don't just want to present some criticisms and complaints, but also provide some suggested solutions. So less is more. Volunteer to do a little bit less, and a little bit of data that's good is way better than a whole lot of data that's bad. When I was a PI on the NEEMO mission this summer, I drew from this crew experience, and when there was a crunch the second day in the mission, and everything was way back in the timeline, everybody was scrambling, the crew was scrambling to get things in, and MCC was scrambling to get things in the timeline, I walked into the mission control and I said, do not do my experiment today. I'm canceling everything, take it off the thing. I spent $25,000 for that 6 hours of the mission. I volunteered to take that out. The crew was so happy. Mission control was so appreciative. Everything calmed down, and I had total allies in the rest of the mission who were motivated to do our task really well. Remember task quality, something Reinhold told me last year for this was test your task on your graduate students after they haven't slept for a few days. It might be perfectly suited to take in the mission based on your normal lab prep. Get your graduate students drunk. You won't have to try hard. Have them come back after a couple days. That is how your crew will be taking your task. That'll help you find some question issues, some survey issues. It'll really help. These little things matter. Put sliders on the surveys instead of inputting numbers. After 40 days, that makes a big difference in crew happiness. And whatever your status is right now, simplify that project a little bit more. It's going to bring returns. Last couple of steps to say, if we want to boldly go where no one goes before, I understand these are some scary suggestions to make for the field. However, report how many surveys your subjects did the days you tested them. I don't see that in a lot of papers in the field because we don't tend to do that. I'll volunteer and go first. In our NEEMO mission, we did a psychomotor control task, and they, on average, were given almost 20 tasks per day and completed 10.5 of them before every task. You know, I think that that's a useful thing to contribute to the methods and let the readers discern as they will. Likewise, the time between EVAs was about 175 minutes before doing our task. And report debriefing comments, that's data too. Have your readers be able to digest and interpret your data based on what the crew reported their experience was while giving it. And finally, and a little bit more boldly and certainly more scary, is show the data from these analogs maybe when they were doing your task. That might not be logistically feasible. However, something to maybe think about for the future, because it'll help graduate students design their future dissertations by reading your papers and designing the next steps. So big team efforts in the field on that front. So finally, wrapping up some key challenges, just to summarize, I see for the future. Construct validity, are we measuring what we think we are? Communicate more with the crew, particularly suggesting more disclosures of what you're not manipulating so that we can be at rest when things are just chilling out. Communicate with the PIs across measures. If you're using the same questions or same measures, communicate, maybe simplify that and share a little bit more data or plan that ahead of time. And team selection is certainly something I didn't have a chance to talk about a lot, but these is one of the core issues in the field that I think everyone here is very committed to and very interested in. Great operators don't always make great research subjects and vice versa. You know, something that we were talking about the last couple of days in the mission or in the conference here is that sort of this idea of having psychological scars really helps survive the crew experience. That is, the depths of space are no place to first flirt with the depths of the human mind. So our explorers have to be marbled a little bit from prior struggles, have that grit, have that adversity, know how to beat that beast when you got to dance with that devil. I think that was very helpful. And adopting that test pilot state of mind will help us because you guys are essential to this final success of getting to Mars, landing our humans, getting them to work together. We get it right, we get to Mars. I think I'm out of time, but I certainly look forward to discussion if anyone has questions later. Certainly acknowledge our teams. Importantly, certainly the HERA mission, Reinhold, Paul, Shelley, Patrice, Kim, thank you guys. Changed my life, career, one of the most amazing experiences ever. So thank you to all you in the room. Sorry for all the data that I gave you bad responses for. Hope you forgive me. But thank you to you guys for the time here. And if anybody wants copies of the slides, I can send them later. You can use that Q code. Anyway, so with that, hand it over to Reinhold. Remember that we're on the same team if you have any questions.